Hi, and welcome to question 5 of the 2020 Ordinary Level Maths Paper 2 for the Leaving Cert. And if you want to copy these notes, just email me at shanetroy@gmail.com. So let's get stuck in. Okay, so question 5 is looks like a trigonometry/geometry question. And even before I read anything, I'm going to try to see if I can figure out anything about the diagram and write it on the diagram. You never know if that'll get your marks if you're stuck. But these are two parallel lines. Now I should confirm that. Short rectangular shaped lake. Okay, so they're saying it's 100 meters wide. So it is. There's two parallel lines. So this is your situation. Two parallel lines and a transversal or line crossing them. Okay. Now it's crossing it that way, and there's another one crossing like something like that. Okay. So what's obvious to me is that this angle and this angle are equal. Now, if I know this angle, okay, I know this one. I might need this, but that would be 180. So the straight line, 180. Take away 55 would be 135. I should check that with the calculator. 60. No, 125. Okay, I don't necessarily need it, but whatever. I should make sure it's correct. Now, I can't offhand think of anything else. Okay, I know this whole thing here is 125, but I don't know which one this is. Without more information. Now, I do know that it is 100 all the way across. Okay, so we do actually know this distance here, for example. It's 100. But that's we're told that, so no point rewriting it. So just read it, and I'm going to clear off the clutter there. Okay, just to make things cleaner. So two swimmers, A and B, stand at the same point X on one shore of a long, still rectangular shaped lake that is 100 meters wide, as shown below. And they say the diagram's not to scale. Both swim to the opposite side of the lake. Okay, so they're both standing here. Swimmer A goes this direction. Okay, swimmer B goes this direction. Now, part A says, swimmer A swims to the left, making an angle of 55 degrees with the side of the lake as shown. So again, you see that. Find the distance A. So find this distance here that the swimmer swims to reach the other side. Give your answer correct to the nearest meter. Right, so look, if you think about it, this is a big triangle. Okay, now it's a non-right angle triangle. You're not told this is 90, even though it kind of looks like it, you can't assume it. But I don't have enough information, even though I do have that as 55. Okay, so I do have an angle and a side, but I don't have another angle or side to use either the sine rule or cosine rule. So I don't have enough information to do anything. But if you make the leap, I do know this length there. So I can break that into a smaller triangle. Now, badly drawn triangle, that's your 55. That's your 90. I've created that line. And that's your 100. Okay, so I know a bit more about this triangle. Now, if I use trigonometry and right angle triangles, now I can't use Pythagoras because I only know one of the three sides, but I can use the trig ratios. So if I pick the first one, okay, so sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is relates to the opposite over adjacent. If this is the angle I'm looking at, that I have, then this 100 becomes my opposite. Now this is my adjacent, and the side across the right angle is always the hypotenuse. Okay, so if I then go, right, well, look, what do I have for this particular formula? Okay, I do have the area, and I have the opposite. So I have two of the three things. So sine will work. It's just a matter of doing it now. I'm going to call the opposite 100, and the hypotenuse, I'm going to call it x, just because whatever. It's easier than writing HYP. Now, the algebra here, if I bring x across the equal, okay, it's going to become multiplied on the far side. So instead of having x on the bottom, I now have it on level. Now, if I bring the sine 55 back across, it was multiplied on the left, it'll become divided on the right. So bread and butter stuff, but again, easy to make mistakes and get the wrong end of the stick. And I often find algebra is the one thing, being consistent is the trick. So I can program the calculator with this. It's 100 divided by, I should make sure my calculator is set to degrees. It is. I was doing work in radians recently. Now, okay, I get 226.6. Okay, 236.6 to the nearest meter. That's 237 meters. So that length there is 237. Now, does that make sense? Okay, like it looks like it would be more than 100. Okay, so I can't say I'm majorly wrong with it. It's not like crazy, number of comparison or negative or something. So that's part A. Now, just on the next page there, it's the answers. Although why did I get a different answer? Okay, I now realize I put in sine of 155 because I'm an idiot. Okay, and that's not what it should be. My calculator, if I just change that to 55, and it's actually 122.07. Okay, so 122.07, which would round to 122 meters. So my bad. I put the calculation wrong. Now, if I had done that in reality, I probably would have went back to the high partial. Okay, but look, and it might be a problem because in the actual answer, in the next parts, I may need to use that. So we'll see. Okay, so that's again, I'm just lucky that I have the answer. I wouldn't have noticed. Even the 237, I went, okay, it's not whatever. It doesn't seem outrageous. Okay, so look, it says not to scale, so it wouldn't have put me off too much. The part B here, it says swimmer B swims to the right and travels a distance of 200 meters. Now, I probably should have taken a screen grab of the diagram and put it in here, okay? But you can always look back, and I'll be doing that myself in a second. So to reach the other side, making an angle of theta degrees. Now, if you don't like theta, just call that A, okay, angle A. Just so you're not worrying about this symbol. It's just the Greek symbol. So making an angle of theta degrees with the bank on the other side of the lake as shown. Find the value of theta. Now, if I go back, okay, I'll even use this image here. That's there. We're looking for this angle here. Okay. Now, I know that this angle here is 55. I know this was 122. So I know more about this triangle. I could break it in half, okay, and make this a right angle triangle, but I'd only have a certain amount of information. I think the sine rule is going to work here. Okay, so let's write out. Once I think the sine rule will work, I can go look it up in the back of the maths tables. Okay, I think I've actually written it upside down, but it doesn't matter. It's the same, but look, we'll go with it. If I say, well, look, my angle A or theta equals A, okay, so sine A is what I'm looking for. Now, if I go back to my diagram, okay, if you notice, this 122 I just found, okay. Now, if I'd gone wrong, it would be fully accepted as correct. And then sine B, okay, if I go back, is 55, okay, relating to 200. So sine 55 over 200. Now, at this stage, if I want to finish off, okay, if I bring the sine across, or the 122 across here, I'm left with sine of an angle equals 122 times everything on the far side. I can leave it like that. My calculator would handle it, okay? Now, if I want to, before I do any calculations, and you shouldn't do them until the end in case you have a rounding error, it mightn't matter, but just in case. If I bring the sine across, it's going to become inverse sine on the far side of everything. So I can just copy what I had there. I haven't manipulated it, so just a matter of putting it in. Now, that's calculator job. So if I bring my calculator up, and again, making sure I'm set to degrees, and I go inverse sine. Now, my calculator may be slightly different than yours, but it should be fairly similar. And that there on top is sine 55. And then down below that is the side of 200. Close the brackets. I can press equal now. It will do the hard work for me. I get an angle of 29. Now what was it again? 29.979. Now they don't ask me to round it to the nearest degree, but look, I can. They don't tell me not to. Okay, so that would be 30 degrees. Now again, I might need to use this if I in the next part. Let's see if I did that right. Now, I used the sine rule, okay, and completely didn't. This is why I get for making videos at like pre 9 a.m. So this side here is 100. So just a different approach. Okay, same angle. If I had realized, okay, that this can be creating a 90-degree triangle. Okay, now that's the angle. Now, so they're looking for this angle here, but if I find this angle down here, it'll work. So we'll call this angle A. This is 200. Now this is 100. So again, we just forgot to, we done that in part A. Then you just go, look, this is the angle I'm looking for. So this is the opposite. This is the adjacent. This is the hypotenuse. So sine will work again. So sine of an angle is equal to 100 over 200. Now for some reason, I forget to call this A all the way through, but look, I started calling it A. And then put the calculator, you get a half. Inverse sine of a half is 30 degrees. The calculator will show you that. It's like one of the standard angles. And that's it. Now, I probably could have used this, okay, triangle here. In fact, I don't know why I didn't. That's 100 there. It would be the same thing though, so it's not a big deal. If I found this to be 30, because of alternate angles, this has to be 30 as well. So look, and the last thing I want to say is just go back a step. I wrote this as sine A over A. The sine rule can be written, and kind of most usually is. I'm not even sure why I wrote it like that, because I normally write it like this, and I can just substitute my values and work it out. Now, so you can use the sine rule. And I've had students in the past who've only used the sine rule. The sine rule will always work, whereas the trigonometric ratios like sine, cos, tan will only work with 90-degree triangles, and they ignore sine, cos, tan, and they just use the sine rule. So look, it's strategy, but it's not necessarily the recommended one. Now part C here, so it says the next day, the swimmers again swim to the opposite sides of the lake, but in slightly different directions. So it's not the same diagram. Swimmer A swims to the left, making an angle of 45 degrees. So again, that's 45, okay, and travels 141.4 meters as shown. Swimmer B swims to the right with an angle of 40 degrees and swims a distance of 155.6. Now it says find D, this big distance here on the far side. Okay. Now if that's 40, I know this is 40 as well. So I actually know a whole pile about that triangle. I know that's 45. I know that's 40. Now if that's 45 and 40, that's 40, 85. Take it from 180, that's angle there is 95. Now one thing that's not is it's not a right angle triangle. This side here is 141.4 and this is 155.6. So we're basically being asked, what's the length of that side of the triangle? Now we know a whole pile. And I could use the cosine rule. I could use the sine rule. The only rule I can't use is Pythagoras. Pythagoras won't work. This is not a right angle triangle. And I couldn't use sine, cos, tan, the trigonometric ratios. So let's go to the answer and see what I did before I went with cosine rule. Now, I found out that 95. So the cosine rule works when you have an angle and the two sides either side of it. And you can use it to find the missing side. Alternatively, and for kind of a more advanced question, if you have all three sides, you can use it to find the angle. Okay. And just depending on how you use it. So that's the cosine rule formula there. I'm looking for A. Okay. So now you could say that A is the same thing as D. I have I'm going to call this side here. Now I call this B and this C, which kind of makes it a bit weird. That's your B value, your C value. Now B and C again, now they're multiplied -2 times B times C times cos A. And then we know the angle is 95. So I have everything on the right-hand side. It's just a matter now of putting it in my calculator, and I would strongly advise you do that. Just make sure you program it carefully, but do show this step. That way, if you do make a mistake, they can see that you had correct input. You'll do fairly well. If I literally drop dead and stop this question right here, okay, you definitely have the high partial. Because literally, it's just calculator work. Now, if I put it to the calculator, okay, I'll get a number, and I'm going to have to end up bringing the square across. Okay, so you get the square root of the answer here is the 219.181. It often happens, maybe 25% of the time. Students forget that and they declare what they get here as their actual answer. But you have to square root it because it's d squared equals that number. I'm not sure why I've never really understood this, why the cosine rule isn't written like this. Okay, bring the square across in advance. So you're just putting the numbers into this as opposed to that extra little step. But, you know, it's not. So I could use the sine rule in that last question just to point out there are often different ways to get to the same answer. This depends on what you prefer or what you think of at that time. Anyway, this is question 5 of the 2020 Leaving Cert Maths paper 2. And if you want these notes I'm using, then get through to me at shanetroy@gmail.com and click subscribe to get access to the other playlists. Thanks very much.